curriculum. So don't fret too much about it in terms of like doing what I just did. Okay, so recursion continued. Yeah, so like I said earlier, the point of recursion, or recursion becomes really powerful, is I have a really, really big problem, and recursion helps me break it down to smaller and smaller and smaller problems until I get to my base case, in which theoretically is the smallest problem, and in some ways the easiest problems that we can solve. Number three, if you want to return something, well, that's what I just did, right? I have a return something. I like at every point, at every function in my recursion, I'm always returning something so that the person who called me or the function who called me can actually use it. And so the return is going to become very, very important too. In this case, so I'm not going to kind of bore you to details necessarily with kind of what these next two slides are showing to the code. But the point here is that like recursion is also very, very useful if we need to do something, but we don't know how many times we want to do it. One example, I keep using the dice roll. But what's something else that I mentioned that, we don't know how many times we have to do it, but we usually have to do it until we stop. Yeah? Totally. What's something that we could use recursion for that requires us to do something where we don't know how many times we need to do it, but we know when we'll have to, like, we know we have to stop at some point. What? Yeah, definitely. The while loop can definitely be written as a recursive function. I've asked you because deep copy is a really good example, right? If I want to create a deep copy of something, I have no idea how many times the things are nested, but I know at some point I should reach an endpoint, right? The nesting should stop. And so if I was to make a deep copy, that's actually a perfect example for when I want to use recursion, right? Because I'm just going to keep going. If it's iterable, if it's an object or an array, I'm just going to keep going, keep going, keep going, until at some point I can say, great, I'm done. So that's what all this is, right? This is saying, look, you can write that with like a if this, then else this, and then iterate through like the list to see if anything else is like nestable, etc., and it becomes very hairy very quickly, and you actually don't know how far deep you need to go. Recursion kind of solves that problem on your behalf. And so this is like an example of a code in which you will use if you want to log through every single element in an array, but you don't know how many levels of nesting it is, you go through, and basically what you're saying is, hey, if this thing has no length, then you stop. Otherwise, if the thing is an array, you call it again. And if it's not an array, you just go through and you log everything. Read through it kind of, when probably, honestly, when you're like more fresh. But like that's essentially what it's doing here. Is that it just does something over and over again until it reaches a finite state.
Wait, sorry, can you go back real quick?
Yep.
So it's taking them away?
Well, in this case, what it's doing is it's actually just only looking at the first element. Say if the first element is an array, recursively run ourselves. If the first element is not an array, just log it out. There's like a number or a string. Log it out, and then run this recursively on element.slice. So run it on everything but the first element. So that way you're kind of just only looking at the first element each time, and then you look at the rest of the array. Yeah.
So at the top it just says, if there's no length anymore, return. Does it like intuitively know that you're just?
Oh no! So this is to capture the very, very actually.
There's no like return.
Well, sorry. In this case, you're not returning anything because the problem was to just log out everything or console log out everything in the array.
Oh, I see.
If you were to recreate it, you would. If you want to flatten it, yes, you would definitely need to return stuff.
Okay.
In this case, we're just turning out to the screen, so we're doing something a little bit different. Yeah, and the first one, I guess I'm actually kind of weirded out by what that is, because in my mind.
Wait, does that not work though?
Yeah, sorry. What does that work?
If element length is false.
Yeah, I
I'm
think.
just kidding, I mean,
Yeah, I think like so. Normally, I stop my reach length of 1. I think this just stops when we reach length of 0. And so rather than having this dot length equals 1, which is what I usually do, it's just saying, hey, if length equals 0, that's when you stop. So they probably do one more cycle than me, but like same exact thing, right? It's just more of a stylistic choice than anything else. Okay. So anywho, Yeah. So recursion, really, really good for indefinite operations. You know when to stop. You just don't know how many times you have to do it until you get there. And recursion in that way does something that iteration maybe cannot do. I guess a while loop could probably mirror that, but it's just become so messy to write a while loop with that level of customization. So a lot of times recursion is the best solution for it. And dealing with nested stuff, recursion is definitely a lot better. So when do you want to use recursion? In the most cases of like things that you guys will be doing kind of at this level, iteration probably covers like 99% of the use cases. I think you want to use recursion more for the sake of practice. So if you ever are in the wild and you're doing a problem, you're like, wow, like, how do I use recursion for this? Try with iteration. You probably get to the same place. And iteration is definitely easier to think about, especially if you haven't had a ton of experience with recursion. Recursion is good for branching. So what we just did earlier, sorting things. You probably find some examples of code where you're sorting things, and recursive sorting is actually really powerful. And then traversing the nodes. I think branching is like something like depth first search. No, 3 is depth first search. But essentially, the idea is that like if you need to go through something and you don't know how many possibilities there are, recursion is probably a really good tool for that. And this is just another reiteration that look, like recursion is hard, and if you are having a lot of trouble doing it, especially for a problem that doesn't ask you to use recursion, use iteration. It probably is a lot easier for you to for anyone really to think through and do, and it's definitely a lot easier to debug. And this is just a rehash of our previous. This is a rehash of the previous slide, which is that remember. Recursion works because we're doing something, we put like a plate on that stack, but before we take that plate off, we need to put another plate on top of it. That's like the basis of recursion from a computer standpoint, is that we're actually taking detours and things are not running linearly anymore. Like we're creating more work as the work goes on. So reverse string. I won't make you guys do this problem, and in some ways like this is literally the same as reverse array. Yeah, if you replace the letters str with ARR, I think you have exactly what I just did for you guys for the last problem. So hopefully this kind of makes sense now, right? But this is literally what I was doing earlier, which is like, hey, to reverse an array, I'm just going to do it one letter at a time. I take the last letter and have someone else reverse the other letters for me. Well, the next person takes the last letter, reverses all the other letters for me, right? Onward, like so on and so forth until you get to the very end. So, ta-da! We have hello, which is 0 plus hell, L plus hell, L plus he, E plus H, and then we're done. So then we just kind of work this. Oh, animation. Very nice. I wonder how long that took us to do. It's okay. It's nice. I like it. I dig it. And ta-da! We're done. Cool. So this is a slide that we've seen already, but just always make sure your base case is well defined and you are sure that you will actually reach it at some point. All right, that's recursion 2. How's people feeling? How are people feeling? Good?
Can we have a beer during the last one?
Yeah, I mean, so that's all the formal things that we'll be like going over.